Section 9.1 through 9.3, Simplifying Exponents Part 1.
All right, so we are going to start simplifying our first example. I'm going to take you step by step. There's going to be one slide per step so that if you get lost, you can go back and watch that one slide and then move forward. All right, so our first thing to do is look at operations. I have a fraction here divided by a fraction times a fraction. Order of operations, we have to move from left to right since it's multiplication and division, and do whatever comes first. So I'm going to have to divide first. But dividing by a fraction is such a pain. So I'm going to change that to multiplication. If I change this operation to multiplication, what do I have to do to the second fraction? You have to flip it around. So that's the first thing I'm going to do. I'm going to rewrite my problem so that I can let me get this out of here so that we can move forward. Okay, so I'm going to rewrite this. So my first one is going to stay exactly the way it is. 9m squared u divided by 6n cubed u squared. But I'm going to change this to multiplication as long as I flip this second fraction. So that 15nu squared is going to become the numerator, while the 24m becomes the denominator. And then multiply by, and I'm going to keep that exact same thing because it's multiplication. I'm not changing where that is. So I'm going to multiply it just like this. So the first step in the solving or simplifying process, to be exact, is to change that sign from division to multiplication as long as you flip that second fraction over. Next slide is going to start from this stage. All right, so we're starting at the next stage that I just left you off. Now I'm going to use multiplication of fractions rule, where you take and you multiply your numerators straight across. Okay, so I'm going to set up my fraction bar, but I'm going to make it long because I'm going to write those fractions. So I have 9 times m squared times u times 15 times n times u squared times 8 times n squared. And then I'm going to use that same rule and multiply my denominators straight across to make it a single fraction. So I have 6 times n cubed times u squared times 24 times m times 10 times m cubed times u. So the only thing I did was multiply 3 fractions to make one large fraction. Now we'll pick up on the next slide at our one large fraction. Here we are at the next step. So we have our one large fraction, one numerator, one denominator. Now I'm going to use the commutative property of multiplication. So I'm going to take this numerator and I'm going to commute it, which means I'm going to put like terms next to like terms. Like variables next to like variables in alphabetical order. I'm going to do that for the numerator, and then I'm going to do that for the denominator. So I need my big fraction bar, and I'm going to commute the numerator. So it's going to be a 9 times a 15 times an 8. I want all the coefficients to jump. So I've used that one, and that one. And I keep track of what I'm doing. Then I need alphabetical order. So I have an m squared, a u, an n, a u squared, and an n squared. Alphabetical order. So m squared comes first, and so that's gone, and I have no other m's. Then I will use an n right here, and then I have an n squared. And the only thing left is a u and a u squared. So I just want to quickly check. I have my 9, my 15, my 8, then I have my m squared, my n squared, my u, and my u squared. I have no factors that remain, and I've commuted the numerator. Now let's do that to the denominator. So I have 6, 24, and 10. So I'm going to go 6, 24, and 10. Now alphabetical, so I look for my m's. I have an m and an m cubed. Go back, look for any n's. I have an n cubed, and then u's. I have a u and a u squared. U and a u squared. Do you see how I kind of put them in order? The m was to the first, then the m cubed, then the n cubed, then the u to the first, and then the u squared. It just helps because you'll see that things start to line up. So now we're going to move on to the next slide. So this slide, all I did was commute the numerator and the denominator using the commutative property of multiplication. So in this step, what I'm going to do is I'm going to focus first on the coefficients to see if I can simplify those. So I'm going to focus right now on this slide just on that purple box, the coefficients. So there's my long fraction bar. But I can see that some of these have common factors in the numerator and denominator. So I'm going to kind of look at them separately. I'm going to look at 9 and 6, 9 divided by 6, 15 divided by 24, and 8 divided by 10. So if everybody sees, I'm going to do 9 divided by 6, 15 divided by 24, and 8 divided by 10. I'm going to simplify those. So it's 9 divided by 6. Well, common factor is a 3. So 9 divided by 3 is 3. 6 divided by 3 is 2. So 9 6 becomes 3 halves. 3 is the new numerator, 2 is the new denominator. Do the same thing for the 15 24ths. 15 24ths has a common factor of 3. So 15 divided by 3 leaves me a 5. 24 divided by 3 leaves me an 8. So 15 24ths leaves me a 5 and an 8. Remember to put that times in there. So everybody see what I'm doing? There's that fraction simplified. There's that fraction. Now I'm going to do this one. 8 divided by 10. Common factor, 2. 8 divided by 2 is 4. 10 divided by 2 is 5. 8 tenths simplifies to 4 fifths. And put that multiplication in there. So now I'm going to focus on my variables. So look at your variables, and all I'm going to use is law 1, the product of powers property. So in this case, I don't have an m squared, any other same basis, but I have 2 n's. So I'm going to keep this as an m squared, but I'm going to use law 1 on those n's. So remember, you need to change the first to a power. To a power. So n to the first times n squared leaves me an n cubed. When the bases are the same and we're multiplying, we add the exponents. Now we can use that same law on my u's. I got to change my first u to a power. U to the first times u squared. You probably can't remember that's u squared, but in your notes you should have it. That changes to a u cubed. So I've simplified. I'm going to use that same law in the denominator. But in this case, I have an m times an m cubed. So I have to change my first to a power, and I have m to the first times m cubed, same base, add the exponents. So in the denominator, remember where you're working. So in the denominator, I have m to the fourth times. Now this n cubed does not have any other common base powers, so it just stays as n cubed. And then my u's, I have 2 of them, so I can use law 1, product of powers property, change the first one to a power, u to the first times u squared simplifies to u to the 1 plus 2, which is u cubed. Now we're going to pick up at the next slide right where we just left off. Now I'm going to break it off again, and I'm just going to look at my coefficients first. Do I have any common factors in the numerator and denominator? And hopefully you can see you do. You have a 5 divided by a 5. So I can cancel those out. Same factor in the numerator as denominator cancels and gives me a value of 1. So now I don't have any common factors that remain between a 3 and a 2, but I do have one between a 4 and an 8. So what common factor remains? I have a 2. So 4 divided by 2 is 2, and 8 divided by 2 is 4. So I'm going to rewrite that as, and here's my long fraction bar again. So I have 3 times, now my new numerator is 2. Remember, you have 3 in the numerator, 5 has gone away, 4 has been simplified and became a 2. And then in your denominator, so there's your denominator, you have a 2 times the 8 got canceled and became a 4, and your denominator of 5 got scratched out. So all I'm left with for my coefficients is 3 times 2 divided by 2 times 4. Now let's look at our variables. So here's our variables. Do we have any common factors? So if we look, we have an m squared and an n to the 4th. Same base, but nothing to cancel because the exponents are different. N cubed, same exact value. So if we have a same factor as in the numerator as in the denominator, these are going to cancel. And then my u cubed. I have a u cubed in the numerator, u cubed in the denominator. Same base, 2 exponent, cancel. So that means the only thing left in my numerator is an m squared. And the only variable term left in my denominator is the m to the 4th. So we're going to pick up right here. You can see I drew my fraction bar a little long. I don't need that extra right now, but I like to draw the extra just in case what's going to happen. So we're going to simplify this in the next stage. Hopefully you can already see some things starting to cancel out. You might be 2 steps ahead of me, but just I'm taking it 1 step at a time. So the next step is to rewrite this. So I'm going to do equals, and I have another fraction bar. I'm going to write it out in expanded form. I have 3 times 2 times m times m. And in my denominator, I have 2 times 4 times m times m times m times m. M squared divided by m to the 4th. So now I'm going to start canceling common factors. So 3 in the numerator, I don't have a 3 in the denominator. 2 in the numerator, I have another 1 in the denominator, so those are going to cancel. M in the numerator with 1 m in the denominator. Another m, I have another m in common between the numerator and denominator. And that's all that I have in common between the two of them. So what do I have left in my numerator? So I have a 3 left in my numerator, and that's it. The 2's gone, the m's gone, the m's gone. You could show your values of 1, but 3 times 1 times 1 times 1 is 3. In your denominator, you have a 4 times an m times an m, and that's what's left in the denominator. So let's simplify what we have. We have 3 divided by 4, and now we could use law 1 on these. Same base, but I have to change them to powers. So m to the 1st times m to the 1st, add the exponents, is m squared. So my final answer for that whole process is 3 divided by 4m squared. Final answer. Hopefully you followed through the steps. Go back and watch any slide where you missed where I went step by step. I'm going to ask you to do one now, step by step, and we'll go over that tomorrow. There is one more for you to watch prior to you trying some.
Simplify the expression. Good luck, guys.